we're going to go over a little bit of cold metal safety um, and some of the tools that we would use and the issues and things that may arise. This stuff is going to be on your safety test, so I want to make sure we cover it. Again, even though we're not actually going to be using these tools, we just want to make sure we understand the safety with these things. So some of the stuff that we will use in here quite often when we're marking metal is a center punch. These center punches have a nice little pinpoint to them. Before you drill a hole in metal, you have to use a center punch. So you take the center punch, you hold it, you hit it with a hammer, and it makes an indentation in that metal. What that does is that helps guide that drill bit in place to make sure that it doesn't walk on you. When we talk about walking, that drill bit will actually move from one location to another as it's spinning. So that little divot that it creates with the center punch helps hold it in place. Now, what happens with these things, because we're hitting them with hammers, and this is the same thing, not just with center punches, but any kind of drift punch, any kind of cold chisels. I think we showed you guys some of that in the tool sharpening gauge, that little cold chisel. We hit them with a hammer, and the ends all look very similar. They all should look like what you see right here. They are tapered down. They do not have what we call this mushrooming going on. And over time, that's going to happen. They tend to, when you hit metal against metal, something's going to give. And this stuff, even though it's tool steel, even though it's strong, it will tend to mushroom out. It's a simple fix for us to do. We just basically take it to a grinder. We grind it back down to where it looks like this one right here. And then after some use, it will start to mushroom out again. The biggest thing with that is making sure that you take care of this before it gets real bad. If you start to see it kind of flatten out before it gets like this, where it's kind of curling out underneath it, you want to make sure that you take those things, you grind them down. It's just kind of tool reconditioning, things that need to happen. It's not complicated. There's not really a science to it. It's really just grinding those things off so that way you don't get little metal splinters in your hand. So it's a simple thing, but it's an easy thing to overlook, and you could end up hurting yourself. If you see some of these chisels or anything we hit with hammers and they start to look like this, we call it a mushroom because it kind of has a mushroom shape. We want to make sure we grind them and take care of them. If we're using corded drills, and even really kind of cordless drills are a little bit different, but this is especially true with corded drills. There is a chuck, which is where the drill bit actually goes into, and then there's a chuck key that will actually turn this. This is a little gear system. We use these to tighten down the chucks to make sure, or tighten down the drill bits to make sure that they don't go anywhere. What happens with these things is if we leave them in the drill and then we turn it on, that chuck could be shot across the room. This is not necessarily true of cordless drills. Cordless drills, we basically take our hand and we can twist it with our hand and we tighten it like that. What you never do with a corded drill or a cordless drill is hold the chuck and then pull the trigger, okay? Tighten it with your hand all the time. I see it a lot where students will hold the chuck and then they'll pull that trigger. That's not safe. If you put a drill bit in, you could end up drilling through your hands, and we want to avoid that as much as possible. If you are changing a drill bit out, make sure that you don't have a battery in there to where it's going to automatically start. If it's a corded drill, make sure that it's unplugged because you don't want this thing to just accidentally turn on you and drill through your hand. Whenever you are drilling any type of material, it's important that it's clamped down into the table. You don't want a piece of metal to go flying around. If you're working with a drill press where it's a stationary machine, you want to make sure you clamp it to the table underneath there. There are different vices and different ways to clamp, but we need to make sure that we always clamp material before we drill it, especially with metal, because metal will grab and it could cause that to spin around, and then now you have a little blade, a little propeller blade that's going to go around and cause you or somebody else harm. When we are drilling, it's important that we don't put a whole lot of pressure down. You can break a drill bit if it's real small, or you can just cause some damage to the drill, or if it slips, okay, you're going to have all that pressure, it's going to go down, and you could cut your hands up. It's easy pressure, let the drill bit do the work. If it's a sharp bit, it's going to work just fine, and you should end up getting these little ribbons, which is little curly cues that essentially come out before that drill's at. If you're getting a lot of real fine dust, okay, probably the drill bit's not sharp, or you maybe aren't applying enough pressure at all. You don't want a whole lot, but you don't want none at all. You have to put slight pressure down, easy pressure when you're drilling through. If you're drilling through a piece of metal that's 1/8 of an inch or thick, you want to make sure that you use an 1/8 of an inch or thicker. you want to use oil when drilling through. Otherwise, the drill bits are going to overheat because it's going to take too long. And when you're cutting, you're creating friction, and that frictions can destroy those drill bits. So make sure that you use oil if you're cutting through metal that is thicker than 1/8 of an inch. If you're drilling through something like a piece of metal, it's always a good idea to have something underneath there. A block of wood is a really great one, like a scrap piece that you don't care about. If you clamp a piece of metal to one of my tables and then you drill through, you're going to drill into the table. And we want our tables to be clean. We don't want them to have a bunch of drill marks in there. So we can put a piece of scrap wood underneath. If it's clamped up and it's in the air, let's say in a vise and it's vertical, you don't need any backing because there's air that's going to be there. So that's if you're kind of clamping it to a table to make sure that you're not drilling into my stuff. We use bandsaws. Okay, the most important thing on these is to kind of check that blade. Sometimes these blades, the teeth will be ground down. And that's because people don't use these things properly. And so when we are using them, you want to make sure that you set the speed down to a certain speed. And we'll have a video that shows how to kind of use this later. But just make sure that you kind of just visually inspect. Everything looks like it's in place. There's no blades missing because if it cuts down too fast, it basically is just going to grind down the blades. Same things happen with hacksaws. Over some time, things do just wear down and we need to replace them. There is a little lever right here that you can actually adjust, and that sets your downward speed. So this thing automatically cuts. You basically set it, you forget about it, and you still got to hang around the machine. You don't leave with that machine running. So that way, if there is an issue or somebody's around there, they don't think that it's off or that it should be off, and they don't shut your work off. So you're staying around the area, but the machine is really just doing all the work. There are clamps on these things, just like we do with drilling. You want to make sure you clamp all your materials down. This clamp, again, I'll demonstrate how we actually clamp it down. But it's important to note that it does need to be clamped because otherwise metal can spin if it's a tubing, or it could be loose and it could move and it could shatter the blade. It could cause some damage to you or somebody else in the shop. So just make sure that we have everything clamped down. Okay, clamps are your best friend. We have our shear and our iron worker. These two are very similar. The shear is on the right-hand side. This is for a thin metal gauge. The shear cuts up to 10 gauge metal. So it's about 1/8 of an inch thick metal that it can cut. It can do a sheet that is 8 feet long. It's got a little gauge in the back. It's a real nice piece that we use to process stuff like the dustpan materials, the feed scoop materials, your tool sharpening gauges. That thinner gauge stuff is really, where that shear kind of does the best work. The iron worker, this one is more used in the welding class, but for thicker metal, this thing can cut up to 3/4 of an inch thick metal, but the width that it can do is not as long. It's not that 8-foot length. So both of these machines have power, but the one thing that we want to make sure with these is we're not putting our fingers underneath this little red guard or underneath that little blue guard. That blue guard comes down and it will smash your fingers as you make a cut. And the same thing with the iron worker, where the shear comes down, it can pinch that metal up into your fingers and it can basically cut the tip of your fingers off. Make sure you set your materials up, you set them in there, and your hands are off the machines when you actually go to cut. There are foot pedals for both of these. You can see one on here. You shouldn't be holding on to anything. These clamp materials will actually hold the metal in place once you have it set up, and your hands can be off of it. Foot pedal goes down, and then it'll make your cut. And then when you lift your foot off, these things will raise up, and then you can make another cut if you need to. When you are done, when you're done cutting, before you start collecting your material, you want to make sure that the machines are off. Okay, there are little red buttons on the iron worker. Sorry, on the iron worker, there's a button kind of behind this guy's hand. It's a red button. All the equipment's going to be the same, where you're going to have red buttons all over the place. On this one, on this little foot pedal there, there's a red button, and then there's a red button right here on the side panel. You can shut these things off by hitting those red buttons. To turn it back on, you have to twist them, and then it's spring-loaded. It'll pop out, and then the machine will be able to be turned on again by hitting one of the green buttons. These ones, okay, again, no hands in there. It's really a one-person job. We shouldn't have 2 people on a machine at once with these things. Generally, this is kind of common sense, but obviously if there's a guard there, don't remove it. Probably one of the biggest culprits I've seen is on an angle grinder. There's a guard that runs on the backside. A lot of people will remove that because it gets in their way and they can't figure out how to work around it, or they don't like it. That guard's there to protect you, okay, as is every other guard on every other piece of machine. Don't wire them out of the way. Don't take them off. Right. Make sure your cords, are good on all the equipment. Any kind of exposed wire, frayed wire, that stuff could be an electrical shock, or can cause a fire as well. So just kind of check those things. If the machine has an issue, and I know we've talked about this in the prior safety PowerPoints, but if a machine has an issue, let me know. Okay. I want to make sure that, if there's something wrong, if it's a safety issue, that we can correct that and we can fix that stuff. If somebody's using a piece of machinery, don't ever talk to them, okay? The power tools that we use in the shop are very dangerous and they could cause a lot of issues. And if you distract somebody while they're working, then they could end up hurting themselves or somebody else. Wait until they're done, okay? And then, go from there. If it's an emergency, we're obviously going to pull a fire alarm, and if somebody's working on something, they should be able to hear that, but for the most part, you don't want to just sit there. You don't want to interrupt them just because you want to chit chat or you want to have a conversation, with them about something. If you're unsure how to use a piece of equipment, do not use it. You can damage, you can break it, you can hurt yourself, you can hurt somebody else. None of those things do we want as an option. So just make sure that if you don't know, you ask and we can, teach you how to use it. I'll be going through and showing you guys how to use the different pieces of equipment, but this is just kind of general safety that we really kind of want to worry about right now. So that should be enough information between this PowerPoint and the last two PowerPoints for you to have enough information to pass your safety test. Remember that we got to get an 80% on that safety test to pass it. You'll be able to take it as many times as you want. If you have any other questions, let me know.